Glacier Peak at Dakobed is the most isolated of the 5 major stratovolcanoes of the Cascade Volcanic Arc in the U.S. state of Washington. Located in the Glacier Peak Wilderness, the volcano is visible from the west in Seattle, and from the north in the higher areas of eastern suburbs of Vancouver such as Coquitlam and Port Coquitlam. The volcano is the 4th tallest peak in Washington state, and not as much is known about it compared to other volcanoes in the area. Local Native Americans have recognized Glacier Peak and other Washington volcanoes in the histories and stories. When foreign explorers reached the region, they learned basic information about surrounding landforms, but did not initially understand that Glacier Peak was a volcano. Positioned in Snohomish County, the volcano is only 70 miles northeast of Seattle. The only volcano closer to Seattle is Mount Rainier, but as Glacier Peak is set farther into the Cascades and almost 4,000 feet shorter, it is less noticeable than Mount Rainier. Glacier Peak is one of the most active of Washington's volcanoes. The volcano formed during the Pleistocene epoch, about 1 million years ago, and since the most recent Ice Age, it has produced some of the largest and most explosive eruptions in the state. When continental ice sheets retreated from the region, Glacier Peak began to erupt regularly, erupting explosively 5 times in the past 3,000 years. It has erupted repeatedly during at least 6 periods. 2 of these eruptions have been among the largest in Washington. Geology. Remnants of past, prehistoric lava domes are main components of the summit of the volcano, in addition to its false summit, Disappointment Peak. Past pyroclastic flow deposits are easily visible in river valleys near the volcano, likely caused by lava dome collapse, along with ridges found east of the summit consisting of ash cloud remains. On its western flank, the volcano also has a lava or mud flow deposit, which runs for about 35 kilometers into the White Chuck River Valley around 14,000 years ago. 10 other pyroclastic flow deposits are visible, all identified as relatively 10,000 years old. There is also a considerably newer mudflow, about 5,500 years old, which covers an area of 15 kilometers between the same river valley, along with 2 small incidents both under 3,000 years old. Another lava of unidentified age was rich in oxyhorn-blende dacity, and continued for 30 kilometers into the Sauk River. There are also ash cloud deposits on the opposite eastern flank of the volcano. Studies of the mountain have to date been unable to find any correspondence with pyroclastic flows, but several past mud flows have been identified. In the Dusty Creek, located by the mountain, there is a lava at least 6 kilometers thick, containing pyroclastic flow deposits and other mud flows. However, this large mud flow is part of a 300 meters thick concentration of past incidents at the volcano that spans the Dusty and Chocolate Creek. In the area, at least 10 cubic kilometers of lithic debris are contained. Tephra deposits are for the most part constrained to the left flank of the volcano, and at least 9 past incidents have been identified. These form several layers of tephra constructing the mountain. Smaller eruptions involving tephra occurred between 6,900–5,500 years ago, 3,450–200 years ago, and as recent as 316 to 90 years ago. On the mountain, 3 additional cinder cones, Dishpan Gap, Indian Pass, and White Chuck, are located about 1,800 meters up. The volcano has also caused such thermal events such as hot springs. There were 3 hot springs on the mountain. Gamma, Kennedy, and Sulfur, but Kennedy Hot Springs was destroyed and buried in a slide. Tectonic Setting. The volcano is located in Washington, and is one of the 5 major stratovolcanoes there. Situated in the Cascade Volcanic Arc, the volcano was created by subduction of the oceanic Juan de Fuca plate under the North American plate. Convergence between the two continues at a rate of 4 centimeters per year. This range has been volcanically active for about 36 million years, and the rocks that make up its volcanoes are between 55 and 42 million years old. Eruptions within the range are irregular and do not occur all at once. In an attempt to organize the volcanoes by age, scientists typically divide them into the High Cascades, younger volcanoes, and the Western Cascades, consisting of the older volcanoes. However, the vents in Washington are all of different ages, so none of its volcanoes are included in either of the sections. History. Around the area, there were many Native Americans, and along with other Washington volcanoes, the mountain was recognized by them as a spirit. When European American explorers reached the area, they learned about the mountain, though only partially, through local legends. Although the local people described Glacier Peak as a vital part of the storytelling and beliefs, when other volcanoes in the area were mapped, Glacier Peak was left out. In 1850, natives mentioned the volcano to naturalist George Gibbs, saying that the volcano had once smoked. In 1898, the volcano was finally documented on a map. Native Americans also used the area around the Cascades for their agriculture, leading them to often congregate in the region. As a result, gold miners eventually reached the area in the 1870s-1890s, searching for resources and rich land. The first white man recorded to observe the mountain, Daniel Lindsley, was an employee of the Northern Pacific Railroad Company searching for possible railroad routes when he saw it in 1870. Eruptive history. Despite its elevation of 10,541 feet, Glacier Peak is a small stratovolcano. Its relatively high summit is a consequence of its location atop a high ridge, but its volcanic portion extends only 1,600–3,200 feet above the underlying ridge. Another Cascade Arc volcano with similar geomorphology is the Mount Meager Massif in southwestern British Columbia, Canada, which is situated on a 1,300 feet ridge of non-volcanic, crystalline and metamorphic rock. Of the 5 major volcanoes in Washington, only Glacier Peak and Mount St. Helens have had large eruptions in the past 15,000 years. Since both volcanoes generate magma of dacitic origin, the viscous magma builds up since it cannot flow through the eruptive vent. Gradually, the pressure grows, culminating in an explosion that ejects materials such as tephra, which in its simplest form is ash. Tephrochronology and radiocarbon dating indicate that Glacier Peak eruptions occurred in 1700 AD plus or minus 100 years, 1300 AD plus or minus 300 years, 900 AD plus or minus 50 years, 200 AD plus or minus 50 years, 850 BC, 3150 BC, and in 3550 BC. The volcanic explosivity index for 3 of these was 2 to 4, small compared to the 5 of the 1980 eruption of Mount St. Helens. They were characterized mainly by a central vent eruption, followed by an explosive eruption. These eruptions varied in outcome, some produced lavas, some pyroclastic flows, and others lava domes. A little more than 13,000 years ago, a sequence of 9 tephra eruptions occurred within a period of less than a few hundred years. Associated with these eruptions were pyroclastic flows, mixed with snow snow, ice and water. These formed lavas that raced into 3 nearby rivers, filling the valleys with deep deposits. Subsequently, the mud flows drained into both the North Fork of the Stillaguamish River and Skagit Rivers. In Arlington, 60 miles downstream, lavas deposited 7 feet of sediment. Subsequent erosion of lava deposits near Darrington led to the current river system, with the Stillaguamish River separated from the Sauk, Skagit rivers. Lava debris was deposited along both the Skagit and Stillaguamish rivers all the way to Puget Sound. A small portion of the erupted tephra was deposited locally. However, most of the tephra reached higher levels of the atmosphere and was transported by the wind hundreds of miles. Deposits from this congregation were as thick as 1 foot near Chelan and 0.3 inches near Missoula, Montana. Since these events, Glacier Peak has produced several lavas. The largest events were 5,900 and 1,800 years ago and were associated with dome-building eruptions. In both cases, the lavas traveled down the Skagit River to Puget Sound. Hazards: when lavas reach populated areas, they can bury structures and people. An example was the Armero tragedy at Nevado del Ruiz, where 23,000 died from an enormous mud flow. Lavas from Glacier Peak pose a similar threat to the small communities of Darrington and Concrete, and a lesser threat to the larger and rapidly growing towns of Mount Vernon and Burlington, as well as other communities along the lower Skagit and Stillaguamish rivers. A 2005 study conducted by the United States Geological Survey identified 9 Cascade volcanoes, including Glacier Peak, as very high-threat volcanoes with inadequate monitoring. At the time of the study, only one seismometer was installed on Glacier Peak that had not worked in 2 years. Glaciers. 11 significant glaciers cover Glacier Peak. When C. E. Rusk first saw these glaciers in 1906, they were beginning to retreat, but were still very advanced. The average retreat of Glacier Peak glaciers from the Little Ice Age to the 1958 positions was 5,381 feet. Richard Hubley noted that North Cascade glaciers began to advance in the early 1950s, after 30 years of rapid retreat. The advance was in response to a sharp rise in winter precipitation and a decline in summer temperature beginning in 1944. 10 of the 15 glaciers around Glacier Peak advanced, including all of the glaciers directly on the mountain slopes. Advances of Glacier Peak glaciers ranged from 50 to 1,575 feet and culminated in 1978. All 11 Glacier Peak glaciers that advanced during the 1950 to 79 period emplaced identifiable maximum advance terminal moraines. From 1984 to 2005, the average retreat of 8 Glacier Peak glaciers from the recent maximum positions was 1,017 feet. Milk Lake Glacier, on the north flank of the mountain, melted away altogether in the 1990s. Recreation. The Pacific Crest Trail passes near Glacier Peak. The Seattle River crossing is a well-known feature on the Pacific Crest Trail as it passes through the area. The Seattle PCT crossing used to have a bridge crossing until it was flooded out by storms in late 2003. The first person to climb the mountain was Thomas Gerdine, along with a group of United States Geological Survey scientists. In 1897, the volcano is also available to skiers. To reach the mountain itself, it takes 5 miles of walking along the White Chuck River Trail and up the Sitcombe Glacier. The trail is reached via Forest Service Road No. 23. Mainly, the slopes consist of black diamonds for both the ascent and descent.